The matrices review 9 through 16. These are being focused on the determinants and Cramer's rule. So first off, let's look at the determinants. And the determinants, remember, are your downs minus your ups. And so your downs, in this case, negative 9 times 3 is negative 27. And your ups are 32. So when I take negative 27 minus 32, I end up with a total of a negative 59. So let's look at the next one. My downs negative 42, my ups negative 15, downs minus ups, minus a negative makes that a plus, and then we find our number is positive, or is negative 27 is my determinant. Now in this next one, we have to duplicate the columns in the first two rows before we do the downs minus ups. So negative 9, negative 2, 0, 0, 1, 6, and then you do your downs. And so your first down product is positive 9. 0 is the next down product. And the last one is going to be negative 60. So when I combine that all together, I come with a negative 51 for my downs. Your ups, the first up is 0, next up is 0, and the third up 0. So my ups are 0. So if I do downs minus ups, gives me a grand total of negative 51. And that's my answer. So now using Cramer's rule. Cramer's rule is when we take and create a coefficient matrix, and we're actually going to find the determinant of that. So the coefficients are the numbers in front of your variables. Negative 3 is in front of my first x, and a 7 is in front of my y. And then the second row, 1, negative 3. And we're going to do downs minus ups, just like we were just doing. So my downs is a positive 9. My ups are 7. So downs minus ups gives us a positive 2 for the first coefficient determinant. Now we're going to take and replace your x column with the answers. And this is, so you'll have the answers and then y's in your determinant. So this would make it a 10 and a negative 15 in that first column, and a 7 and a negative 3 in the second. So again, you're going to do downs minus ups. So your downs in this case is negative 30. Your ups are a negative 105. Downs minus ups, negative 30, minus a negative 105, minus a negative is a plus. And so we end up with a positive 75 for that determinant. And then the last one we have is our coefficient with the y's replaced. And so our x's are going to be the negative 3 and 1. And then you do your y's with the answers, 10 and negative 15. So x and then the answers. And your downs, in this case, is going to be a positive 45. Your ups are going to be a positive 10. So when you do downs minus ups, your answer is a positive 35. But you are not done after you find those determinants. You need to use them. So to find your x, you will take your coefficient with the x's replaced determinant divided by your coefficient determinant. And this is where if you end up with a 0 for your coefficient determinant, that means that there is undeterminable solutions. And that's whenever you say there's no unique solutions. 75 over 2. That can't reduce, so 75 halves is your answer for your x. Next, we're going to do your y's. The same y, except for with the coefficient with the y replaced being your numerator, over the coefficient matrix. And so that's going to put us at 35 divided by 2. So 35 halves when that reduces. So your answer is an ordered pair, 75 halves, comma, 35 halves. Then we're going to do it again on number 13. So you first create your coefficient matrix. And so we're going to find the determinant of it. So that's going to be 2, negative 1, 1, 1. Your downs are 2, and your ups are a negative 1. Downs minus ups is 2 minus a negative 1. We add those. And that gives you a total of 3 for your coefficient matrix. Then you're going to do your coefficient matrix with the y's replaced. Coefficients with the x's replaced first. And so that's going to be negative 12 and 4. And then your y's are negative 1 and 1. So your downs minus ups, your downs will be negative 12 times positive 1, which is a negative 12. Your ups will be a negative 4. So that's going to give us negative 12 minus a negative 4. Minus a negative becomes addition. And that gives us a negative 8. Then we're going to do our coefficients with the y's replaced. And so that's going to be the 2 and the 1 in the first column, and the second column is a negative 12 and a 4. So you do your downs, 8, minus your ups, negative 12, 8, minus a negative 12, minus a negative is addition, and that gives us a positive 20. So now we're going to find our answers. So to find your x's, you're going to do your coefficients with x replaced. divided by your coefficient matrix. And so in this case, that's going to be a negative 8 over 3. And that's as reduced as it gets. Now we're going to do the same thing, but for our y's, we're going to do the coefficient with the y replaced, divided by your coefficient matrix. And that's going to be 20 divided by 3, which is as reduced as that gets. So our ordered pair is negative 8/3 and 20/3. On this one, you do not have to get the solution. Just set it all up. And so we're going to set up our 4 different matrices. So starting off with our coefficient matrix. And that's going to be negative 2, 1, negative 6, 1, negative 6, negative 7, 1, negative 1, negative 1. Then I am going to go to where I'm doing the answers. And for the x spot. And then everything else is going to be the y and the z. So I'm going to do the coefficient matrix with the x's replaced. And so if I replace the x's, that's 18, negative 21, and negative 13. Everything else is going to be the same as what we just had. 1, negative 6, negative 1, negative 6, negative 7, negative 1. Then you're going to do the same thing for your coefficients with the y's replaced. This time we're going to do your x's, then your answers, then your z's. So my x column was negative 2, 1, 1. The answers were 18, negative 21, negative 13. And then the z's, negative 6, negative 7, negative 1. And then the last one, we have the coefficients with the z's replaced. And so for that one, you have your x's and the y's normal, and your z's are the answers. And so the x's were negative 2, 1, 1. Your y's were 1, negative 6, negative 1. And then your z's are going to be replaced with the answers, which are 18, negative 21, and negative 13. You do not have to solve this. You're just setting up the matrices. So these are your 4 different matrices. And it's all you're having to do in this problem. Do not go to the part you have a solution. You're just setting it up. On the ones you're actually having to solve, you are going to be given the determinants already solved for you. And so on this first one, to find our x's, you take the coefficient with x replaced divided by the determinant of the coefficient matrix. And so that's going to be a 0 divided by negative 4, which is 0. Then you're going to do the same thing for the y's, except for we're going to be using the coefficient with the y replaced divided by the coefficient matrix. And that's going to give you 2 over negative 4, which reduces to negative 1/2. And then the last one is going to be your z. So you're going to take the coefficient with determinant of the coefficient with z is replaced, divided by the coefficient matrix. So that's negative 10 divided by negative 4, which reduces to a positive 5/2. And so you're going to write the ordered pair for your solution, or triplet, excuse me. And so the first one is 0, comma, your y value, which was negative 1/2, comma, your x value, which is 5/2. Anytime that you have your coefficient matrix with nothing replaced is 0, that means there are no unique solutions. And you just have to tell me that. Now let's do the last thing, which is find the inverses. And that's going to be in the next video.